Welcome back, guys, and here we'll be going through the next set of questions. So let's move on from number 10. So the cumulative frequency graph shows information about the length in minutes of each of 80 films. Okay, so just for those who don't know, a cumulative frequency is basically adding up all the frequencies as we go along. So that's why from the beginning, if we look at the length in minutes, we can say for up to 80 minutes, no films are watched. But films that lasted for, let's say, 100 minutes, we can say that there were definitely up to 15 films. So of course, films up to 140 minutes, that counts for every single 80 films. So that's how it goes. It's always going to increase. Cumulative frequency graphs never go down. They always go up until they reach the maximum. So let's look at the question now. So use the graph to find an estimate for the interquartile range. So this is the IQR, guys. Now this is just simply the upper quartile minus the lower quartile, hence the name interquartile. Now if we look at carefully, we know that there are 80 films. That means the upper quartile is of course going to be the third quartile. So in your calculator, we need to find the third quarter of 80. So literally write 3/4 times 80 and you should get 60. So looking at the 60th. And to find the lower quartile, we need to find 1/4. And 1/4 of 80 is, well, 20. So we're going to try and find out the actual difference. So all you have to do is go across this line, hit the 60 value and see what value that is. So according to the graph, if you look carefully, that looks like it checks out what? 123. So let's just make a little point there, yeah? All right, 123. Now, as for 20, if you go across, it looks like it's bang in the middle. It's bang in the middle between 100 and 105. So I'll say about 102.5. So always mark this down, 102.5. And therefore the IQ is just 123, take away 102.5. So let's put that in the calculator. So 123 minus 102.5. And you should get about 20.5. So that's it. That's literally the range of minutes between the third quarter and the lower quartile. They'll probably accept answers between 20 to 21, just in case, but don't hold me to it though. Now let's go on to the next part. So Claire says more than 35% of these films are over 120 minutes long. Let's check this out. Let's find out 120 minutes. So 120 is there. If we go up, it checks over there. And if you go across here, that checks that over here. And what's that? I think it's in the middle of 15, 60, isn't it? So we've got 1, 2, 3, 4, 5. So this tells us that up to 55 films have a length of 120 minutes. But we care about over 120 minutes. So we're talking about after it. So the first 55, of course, have movies that last up to 120 minutes. But if they're over 120, that's going to be the remainder area. So that's going to be the remainder after. So it'll be 80 minus 55. So it'll be the 25 films not accounted for. So that's it. So if it's 25 films out of 80, let's see what percentage that is. So you got 25 over 80. And if you want to change the percentage, well, just times it by 100. Put this in your calculator. I mean, I'm doing this literally all from scratch, guys. And of course, I have checked the answers and stuff, but we have to check together. So I got 31.25%. So yeah, so the answer is no. So is Claire correct? No, because only over 31.25% of these films are over 120 minutes long. So the answer is no, because of this. Yeah, so that's it. So that's this question done. And again, if you guys enjoyed this video so far, give me a like and let me know if you understand the explanation, yeah? Because sometimes we have to really thoroughly break it down. Anyway, let's move on to 11. So expand and simplify 2x minus 1 and so on. So these triple bracket problems are so easy. The trick is to always use FOIL on the last two brackets, or at least two easy brackets. And then once you tidy that up, use FOIL again with the new bracket and the first one. So let's do this out. So tip, copy the first bit, use FOIL on the second bit. So if you're not sure how to do it, it's always x times x, x times minus 5, and then 3 times x and 3 times minus 5. So what does that give us? X and x is x squared. X times minus 5 is minus 5x. And then 3 times x is 3x. Combine these two, you get minus 2x. And then 3 times minus 5 is minus 15. So just a quick and fancy way of doing it. Next, and I'm going to change the color of my pen. We're going to use FOIL on the next bit. So 2x with x squared with 2x and then 15. And then do the same thing with 1 with the other 3. So that's literally it. This is literally the extended FOIL method. Now, timesing everything by 2x first, the second bracket by 2x, you should get 2x cubed minus 4x squared minus 30x. And now there's a nice, cool way of doing this. Always try and line it up by powers, yeah? So once you've done the first term, move to the second, shift it across. So here we're going to times everything by minus 1. So x squared times minus 1 is minus x squared. So again, write it below the x squared bit. Minus 1 and minus 2x is plus 2x. And then minus 1 times minus 15 is plus 15. So you can kind of see what I did here. I literally just lined up nicely. And when you do that, and you add them all up, you collect like terms. You got 2x cubed plus nothing is 2x cubed. Minus 4x squared and minus x squared gives us minus 5x squared. Plus 2x minus 30x is minus 28x. And then plus 15. And that's it. Fully expanded. Trust me. Quick and easy method. I really recommend you guys follow this way. Now B. Solve this quadratic equation when it equals 0. Show you're working clearly. Okay, this one tip. When you have questions like this and they say give the three single figures and it's quadratic, use the quadratic formula, yeah? Now, I cannot even remember if they actually give us the formula here because I've been used to doing the old papers and yeah, they actually give it to you. So here's our formula. So the solutions are always in this form. ax squared plus bx plus c. In other words, make your formula always equal to 0. And then everything is either a or b or c. And then smash into this formula. So if you guys don't already know, I recommend you try to memorize this anyway. So let's go back to the question. So let's see, what is it? Number 11, yeah? So let's have a look. So using the formula, we've got x equals minus b plus minus the square root of b squared minus 4ac over 2a. My students usually think of this as b squared minus Yasin, so my name, but think of it as a 4 instead. So putting all the values, looking at the expression, we've got 3x squared, so we've got a is 3, so a is 3, b is 6, and c is minus 5. And when you put this in, always wrap it around in a bracket, especially the 4ac bit. So we can say therefore x equals, so minus 6 plus minus the square root of 6 squared, which is 36, minus 4 times 3 times minus 5. So remember, wrap in a bracket over 2 times 3. Yeah, so have a go at this one. So be very careful when you enter it in, yeah? And then when you input all of this, you should get hopefully some decent answers. So let me have a look. Actually, no, you're going to get 3 significant figures. So I'm going to get, so putting this carefully and then using the plus solution, you should get something like, let's see, x is about 0.633. So again, 3 significant figures. And then when you use the minus buttons, remember the plus minus means first you put the plus bit, and then you just go back in the calculator and switch that plus to a minus. And then your other answer should be minus 2.63. Again, 3 significant figures. In other words, 3 numbers that doesn't begin with a 0. Okay, yeah, so easy so far. So 10, 11 haven't been so bad. Now here we go, 12. So diagram shows 2 straight lines drawn in a grid. Okay, so you got a straight line with this equation here and another straight line with that equation there. And you can see that they're intersecting here. So usually when they're intersecting, we can solve them simultaneously using simultaneous equations, yeah? That'll give us the exact coordinate. But here you can see this is intersecting at 3, 4. Now, write down the solution of the simultaneous equations. That means where did they intersect? Well, 3 and 4. Easy. Now, show by shading on the grid the region defined by all 5 of these inequalities. Okay. All right, here we go. So this one, you guys literally get your graph paper ready. We're going to try and do this. So have a look. So we've got 5 equations. They've already drawn 2 straight lines for us. So that looks like these last 2 here. Okay. However, they have not drawn x plus y greater than or equal to 4. Now, this is easy to draw. My tip is firstly make y the subject and just literally find 2 coordinates, plot it in, and then draw a straight line. For example, over here, let's say we make y the subject. So we have y equals 4 minus x. Remember, throw x on the other side. Make a nice little table, x and y. Plug values for x, easy ones. So for example, when x is 0, you get 4 take away 0, which is 4. When x is 1, you get 4 take away 1, which is 3. And that's your coordinates, 0 and 4, and 1 and 3. So plug it in, you got 0 and 4, so 0, 4 is there, and then 1, 3 is here. So so it's quite straightforward. It's literally just a simple straight line. So I'm not using PowerPoint this time, so oh god, that's awful. Yeah, I can't really draw a straight line with this tool. But anyway, that's the idea, yeah? And you can just literally extend it if you want. So yeah, something like that. Now it tells us that x plus y is going 4. So now we've drawn the lines, that's perfect. So as for these two lines, this is easy. This tells you that x values need to be greater than or equal to 0. So we look at the x-axis, and it's greater than 0 when it's over here. So we're looking at values above the x-axis. In other words, we are not interested in this bit. Likewise, for y greater or equal to 0, we're looking at the y values greater than 0. So here's the y-axis. When it's bigger than 0, we're looking on the right side. So we cross out the left. Remember, the left side is negative, so it doesn't count. So in this case, even though it says labeled region R, it's always good to cross out the sides you don't need, the areas you don't want, yeah? So again, guys, if you're not sure what's happening, drop me a comment. I'll try and explain it step by step again. So yeah, make sure you use a ruler as well, not like me, yeah? Okay, let me change the color pen. Now let's get to this bit. X plus y greater or equal to 4. To get this right, I do something known as a true and false statement, yeah? So for example, x plus y is over here, so I should label this line. X plus y greater or equal to 4. So we can see we've got this line here. So I will draw a line like this, call this side either true, false, and this is true, false. The tip is to pick a coordinate from either side and just think when it's true. Now it tells us that these two coordinates, x or y, the sum of them has to be bigger than 4. You can easily see is that if you pick a coordinate like 10 and 10, you get 20, which is clearly bigger. So this means this right side must be true. Then the left side of this line must be false. Because if you pick any coordinate on the left side, you'll get an answer which is less than 4, which is obviously false. That's it. Now for the next line, let's have a look. Which line should we do? Let's do the 3y one. So we're doing the second of this one here. So again, do the true false statement. So we have to pick a coordinate from either side of this line. So let's pick, I don't know, let's pick again 10, 10 because it's easy to work with. Okay, so 10, 10. So we're going to see if this side is true or not. So using this coordinate, plugging in 10, 10, we're going to see if 3y is less than or equal to 2x plus 6. So when you've got 10 for y, you're going to have 30. Is it less than or equal? 2 times 10, which is 20 plus 6, so it's 26. So this is clearly false. So this means that this side was false. So we cross out the side on the other side of the line. Okay, so I hope you guys are getting it. If you already got it, that's good. But now we're going to determine if it's going to be this is true or this is true. So our final equation will be 4x plus 3y. So we're going to look at this line now and just pick a coordinate again. On the right side, I'm going to pick, I don't know, maybe this coordinate. So we're going to check if this side, the right side of this line is true. And this is what? 10, 3, yeah? So looking at the final coordinate and testing 10, 3. What do we have? So when x is 10 and y is 3, we're going to have 40 plus 9, which is 49. So is 49 less than or equal to 24? Nope, it's false. So I'm getting another false statement. So this means this side must be false. So that means this is gone. And all that is left is this little region here. So oops, don't want to make it that too long. So all that's left is this little region here. So this means this is the region that they want. Okay, and that's it. That's literally it. That's all you have to do for this question. I mean, it is kind of long and it's only worth 30 marks. You guys might have a faster method, but this is just a guaranteed way to get it right and not make mistakes. Well, I hope so. Anyway, let's move on to the next bit. Okay, 13. So L, M, and N are points on a circle, center O. QMT is the tangent on the circle M. So it's talking about this line right here. And tip, when you have a center and you have a radius connecting to the tangent, it's always right angled. So this is always right angled to the center, yeah? Keynote. Now, find the size angle NOM, norm. So NOM is from NOM. We're talking about this bit. And this is easy. Basically, the angle at the center is always twice the angle an angle as circumference. So wherever this is always 2 times this value here. So always think of this like shape like that, yeah, or whatever. This is always 2 times that angle there. So if this is 27, that's 2 times 27. So it should be 54. And here's a proper definition. If you guys got a CGP book, and I highly recommend it, I'm talking about this point here, number 5. It says that the angle at the center of a circle is twice the angle at the circumference. And this is the exact answer you can use for your solution. So I want to just literally say this is going to be the answer we want. The angle at the center is twice the circumference. So angle at the center is twice the angle. So here's twice the angle at the circumference, i.e. twice 27 at the circumference. Okay. Ooh, handwriting not that great today. Now next one, find the angle of NMQ. So again, look at this other problem. So NMQ, where do we start? So we start with N, go to M, and go to Q. So we're talking about this gap here. Now this one's a bit annoying because this one's actually part of something known as the alternate angle segment theorem. So what it tells us is that the angle over here from between the tangent and the chord, so this is a chord, yeah, is equal to the angle on the other side of the chord, i.e. 27. So we're talking about this chord, and by the way, we're not talking about this angle here because firstly the angle has to hit the circumference. So wherever this angle is, this has to equal the angle on the other side of the chord, okay, which is here, the one that hits the circumference. And this is part of this property here. So it's best I just show you actually. Again, this is something you have to properly study. So the alternate angle segment theorem is here. So for example, here's the chord. You know, it looks quite different, but we're talking about a simple chord and a tangent. If you imagine this chord, it's going to be on the other side of the chord. So I always draw an arrow from here touching the angle. And we just say the angle between the tangent and the chord is always equal to the angle in the opposite segment. Done. That's literally all you say. So angle, so yeah, 27. Angle between a tangent and a chord is equal to the angle on the other side of the circumference, yeah. Okay, so yeah, so again, try and draw arrows bouncing off it. But yeah, I hope so far this is helping, guys. Yeah, I mean, let me know, of course, like how you're doing with that. Now let's look at 14. So the function f is such that fx equals 3x minus 5 over 4. Okay, find f minus 7. All right, this is easy. Just replace x with minus 7 and smash in a calculator. So it's just going to be 3 times minus 7 minus 5 over 4. Okay, so I haven't put that yet. When you do this, you should get minus 5 over 4 minus 13 over 2. I mean, you can leave it as a fraction or a decimal, yeah? Let's double check. Yep, easy. Now, express the inverse function in this form. So the inverse function is, it's quite easy way to look at it. All you have to do is literally rotate the letters. So just imagine fx is y, yeah? So now all you have to do is copy this function now, but replace fx here with x and replace all the x's with y. So be x equals 3y minus 5 over 4. That's it. So just literally invert these letters, yeah? Function that is y, call it x, replace x here with y. Now all you do is make y the subject. So to do that, firstly times 4 across, so clear the fraction. So you can have 4x equals 3y minus 5. And then add 5 across and divide by 3. So you should get 4x plus 5 over 3. And that's it. And that is your inverse. It's literally so easy. Now, next one. The function g is such that gx equals the square root of 19 minus x. Okay, find the value of f g3. So what this means is that g3 has to go inside f. So my tip is firstly work out what g3 is. So replace this function of 3. So firstly, g3 is literally the square root of 19 minus 3, which is square root 16, which is 4. I mean, I'm not sure this is positive or negative, but I think for this case, let's just say plus minus 4 just to be safe, yeah? Okay, it says find the value, so I'm going to assume it's positive, yeah? Let's just assume it's positive because they don't really say anything. And then G3 is 4, then all you do is plug in the value 4 into the f function. So go back to f, replace 3x minus 5, replace x here with 4. So it'll be 3 times 4 minus 5. So it'll be fg3, which is now f4, which is 3 times 4, minus 5 over 4. That's it. And then whatever that is your answer. It's 4 minus 5 over 4. Yeah, and I got 7 over 4. Wait, is that right? Yeah, I think it is. Okay, not bad. Now, here's the final bit. So this is just your understanding. Which values of x cannot be included in any domain of G? So this is talking about when you look at this function, what values of x can we not use? Well, we're dealing with a square root function. And we should know that in the square root, you cannot have negative values inside. So essentially, looking at this, 19 minus x cannot be, well, less than 0, yeah? So it cannot be less than 0, okay? So what this means is that if you rearrange and make x a subject, you can say 19 cannot be, well, x cannot be greater than 19, okay? So we can say x. So which values can we not include? So values of x that are greater than 19. So yeah, if it said excluded, you would use this option. If it said values we cannot include values bigger than 19. But for example, the square root of 0 works, so you can have 0 inside, but you can't have values less than 0. Yeah, but anyway guys, I hope this section helps so far. I mean, give me a like if it's helpful. Otherwise, see you guys in the next set.